Hi guys, it's Miss B. Today we're going to use the first principle to find the derivative of an equation. So I'm just going to draw here on the side general equation. So y is equal to f of x and label, I'm going to label the x-axis. So I'm just going to put here x and then y. So, and before I continue, what I'm going to do here on the side, just to mention something that you have seen before, and it does look like this. So, and we call it linear equation. So, and maybe you do remember that linear equation has constant slope, and the way that slope, which we label with m, has been calculated. It was, we talked about rise over run, and then we did mention that we do need 2 points in order to find the slope. So point A, point B. So I'm just going to label here point A, point B. So point A, x, y, and point B, x1, y1. So, and then using those 2 points, we found the slope. Rise is the differences in y. So we can go y, take away y1, and run is differences in x's, x, take away x1. So, and that was it. So pretty much everyone was fine with that. And now we do come to find the derivative function using the first principle, and it sounds like, wow, so how are we going to do that? It's actually very similar to finding the slope of the straight line. But what's happening here, now we don't have straight line, we do have curve. So, and to find the slope of, this curve, we're going to connect those 2 points, and I'm just going to use different color. So I'm just going to connect those 2 points and create a line. So this line is called chord. So point A and point B. Now, if point A has x coordinate, so therefore point A has x and f of x, which is the y coordinate. And if you just add any number to x, for example, if we add any length that we're going to call or label h, then this point here is going to be x plus h, which actually it does give us point with x coordinate x plus h and y coordinate f of x plus h. Now, we do have 2 points, and using those 2 points, we can actually find the slope of this chord. So using the same principle that you have seen before, so we're going to do rise over run. So going y, y1, take away y or y1. So it's f of x plus h, take away f of x. So this is our differences in rise over run, differences in x's. So if we have started with this y coordinate first, then we have to use this x coordinate first for the run as well. So it's x plus h, and then take away, now the x coordinate of the point A is x. It does look like that x's are gonna cancel out. So, and we will be left with f of x plus h, take away f of x over h. Now, this is the slope of this chord. But if we do let B approach the A, so B is now getting closer to A. So it's getting so close that we may have here another B dash or something. So, it's getting so close, so that it may look like it's the same point as A, but if you do zoom in, you may realize there's a small line between those 2 points. And to find the chord, find the slope of that chord, you use the same principles. You use, rise over run. But if B is approaching A and getting so close to it, so the gradient of the tangent, so it's going to approach the gradient of the tangent of A. So the gradient of the tangent at the general point x, f of x, is then equal to, therefore it's equal to limit as h is approaching 0. H is approaching 0 because B is getting so close to A, which means that this H is getting smaller and smaller, getting close to X. So close, it's approaching 0. And then we have f of x plus h, take away f of x, and over h. So what is this called is actually, we call this finding the derivative of the function using the first principle. Maybe you have seen different notation, f dash of x, which is called the first derivative of the function. You may have seen dy dx, so but pretty much is the same thing, so it does represent the rate of change of this function. Now what I'm gonna do next is actually have an example, and let's see how we're gonna go with that. Okay, so I'm gonna go with this example. F of x is equal to x to the power of 4, and then find f dash of x using first principle. So first principle now, just to remind ourselves, is the same as limit, first derivative is the same, is equal to limit h approaching 0, so f of x plus h, take away f of x and over h. So it's equal to. Now, if you do remember from before, so when you do have a function f of x is equal x to the power of 4, and for example, if you do choose x to be equal to 1, so let's say f of 1, now what you did before is every time you see x, this x will be replaced with 1. So it's 1 to the power of 4, then it's going to give you 1. So similar is happening here. So it's happening here. So it says f of x plus h, which means now limit h is approaching 0. So it means now using the same function here, but now instead of x to the power of 4, every time we come across x, that x will be replaced by x plus h. And now we just have to remember, because this x is to the power of 4, so we have to put here to the power of 4. And then take away f of x. F of x is original function. So x to the power of 4. Now this is equal to limit h is approaching 0. So, and we're going to use now binomial expansion. So I'm not going to spend much time here explaining, how to expand, because I may record a video about, how to expand binomial expansion. I'm just going to go with x to the power of 4 plus 4x to the power of 3h plus 6x to the power of 2h to the power of 2 plus 4x h to the power of 3 plus x to the power of h. So that's our expansion. And then take away x to the power 4. I'm just going to erase this part here. Yeah, so I'm going to need more space. And so that has been expanded, equal to. What we're going to do next, we're going to see if we can actually cancel out anything. So x take away 4 and x take away 4 is equal to 0. And the next step here is to see, can we collect like terms, or if we can't, to see if there's any common factor. So looking at every single term, we can see we do have some, we don't actually have x's in common, but we can see that every term has age in common. Age in common, which is beautiful because that is exactly what we need. So I'm just gonna take 1 in front and then copy everything else, or what's left. So, and I'm just gonna mention why it's important to have this age in front. As you can see, in denominator we have age. So, and at some stage, this age, we had to sort of get rid of it. So, looking at this statement here, age is approaching 0. What we're saying here is like that's limiting value. Age is getting so close to 0 that we may say that actually is equal to 0. But then it's going to raise a problem. So if we do say it's equal to 0, we can't replace this age with 0 because we can't divide by 0. So therefore, we're looking here if we can have anything in common. So, and when you realize, yes, we do, now what we can do is like, yep, just cross it out. And, this is not going to affect anything. So, but what more thing, what I'm going to say here, it is age can't be equal to 0. So, now when we have, so that's beautiful, has been sorted out. Now we can replace age with 0. So we're going to go back here, 4x to the power of 3 plus 6x to the power of 2, age replaced by 0 to 0, plus 4x 0 to the power of 2 plus age, actually 0, we're replacing it, yep, 0 to the power of 3, so, and then equal to, so that's going to be equal to 0, that's going to be equal to 0, that's going to be equal to 0. So we are left with 4x to the power of 3. So this is the first derivative of the function x to the power of 4. I think I'll just